I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will briefly discuss about agents and environments. In the study of artificial intelligence, understanding agents and their environments is fundamental. Agents are systems that perceive their surroundings through sensors and act upon them using actuators to achieve specific goals. The environment refers to the external context in which an agent operates, and it can be dynamic, static, fully observable, or partially observable, etc. By exploring the interaction between agents and environments, we learn how intelligent systems make decisions, adapt to changes, and solve real world problems. This knowledge is essential for designing AI solutions such as autonomous robots, virtual assistants, and traffic management systems, etc. We'll see one by one. First, we'll see the definition for this agent and then what is environment. The agent is any entity that can perceive its environment through sensors and take actions to influence that environment using actuators. The agent's primary function is to interact intelligently with its surrounding to achieve specific goals or objectives. See here, this is the sensor perceives environment and actions. Sensors allows the agent to gather information about the current state of the environment, while the this is actuators, enable it to perform actions that bring about changes. Agents can range from simple systems like a thermostat that senses temperature and adjusts heating to complex AI systems such as autonomous robots, self driving cars, or intelligent software programs. The behavior of an agent is guided by its agent program, which maps percepts, that is input from the sensors to actions. This interaction between perception and action forms the foundation of intelligent decision making, enabling agents to adopt, learn, and respond effectively to changes in their environment. Understanding agents is essential in the field of artificial intelligence as it allows us to design systems capable of solving problems and performing tasks autonomously in both physical and virtual environments. Let us see the human agent. You know that what the human agent will do. A human agent is an individual, let us take ourselves, who interacts with the environment through various sensory and motor systems. What are all the various sensory and motor systems? The sensors of a human agent, such as the eyes, ears, and other sensory organs, allow them to perceive the world around them. The eyes provide visual information, and the ears detect sound, and other organs like skin, nose, and taste buds contribute to the perception of touch, smell, and taste, respectively. These sensory inputs are processed by the brain to form a coherent understanding of the surroundings, that we are calling it as the environment. On the other hand, the actuators of a human agent, such as what are all the actuators we have, such as hands, legs, mouth, and other body parts. It enables action and interaction with the environment. The hands allows for a fine motor control and manipulation of objects. What is the function of the legs? The legs enable movement and locomotion, and the mouth facilitates communication, eating, and breathing. These actuators are controlled by the brain and nervous systems, which coordinate physical responses based on sensory inputs. That means ears, eyes, etc. In this way, the human agent continuously interacts with and responds to the environment, adopting through sensory feedback and motor action. So the next agent, what we'll see is a robotic agent. It operates through sensors and actuators that allow it to perceive and interact with its environment. The sensors of a robotic agent, such as cameras and infrared range finders, are designed to gather information about the surroundings. Cameras, what it will do, it captures visual data similar to human eyes, enabling the robot to recognize objects, navigate spaces, and interpret visual cues. What is the function of infrared range finders? It, on the other hand, use infrared light to measure distances to objects, helping the robot to detect obstacles, map its environment, and avoid collisions. These sensors provide the robot with crucial data to understand its position and surroundings. So, in this case, actuators in the robotic agent, the actuators of a robotic agent, typically various motors, are responsible for carrying out actions based on data received from the sensors. Motors drive the movement of robot, where it's for locomotion, rotating, and manipulating objects. For example, wheels or tracks powered by motors enable the robot to move across the surfaces, while servos or robotic arms can manipulate objects with precision. These actuators work in conjunction with the robot's control system, which process sensory information and determine appropriate actions. The combination of sensors and, in this case, the combination of sensors and actuators allows a robot agent to perform complex tasks, adapt to its environment, and execute a wide range of operations autonomously or under human guidance. Next, software agent. So we have sensory input and actions. We'll see one by one. A software agent operates with a digital environment, utilizing sensory inputs and performing actions based on data it receives. The sensory inputs for a software agent typically include, what are they? Keystrokes, file contents, and network packets. Keystrokes are captured when a user types on a keyboard, allowing the software agent to respond to user commands or inputs in real time. File contents. What is the function of the file content? File contents are read or processed by the software agent, enabling it to analyze, modify, or extract information from files on a computer or server. Next, network packets or refers to a data transmitter over a network which the software agent can monitor, receive, or send, facilitating communication with other system or agent. So here the action. The actions of a software agent are driven by the sensory inputs it processes. Displaying on the screen is a common action where the agent generates visual outputs based on user interactions or data processing, providing feedback or information to the user. Next, writing files is another action where the agent creates, updates, or stores data in files for future use, logging, or sharing. Sending network packets involves transmitting data over a network, enabling the software agent to communicate with other systems, send requests, or retrieve information. Together, these sensory inputs and actions allow a software agent to interact with users, process data, and communicate within a broader task autonomously or based on user instructions. So the next agent will see intelligent personal assistants. Intelligent personal assistants or agents designed to help users with a variety of everyday tasks. These tasks include scheduling appointments, sending messages, setting reminders, and providing quick information. They interact with users through voice commands and or text inputs and utilize artificial intelligence to understand and respond effectively. Popular examples of this intelligent personal assistants include Siri by Apple, Alexa by Amazon, and Google Assistants, which are widely used to enhance productivity and simply daily activities. Next, we will move on to the autonomous robots. Autonomous robots or agents designed to operate independently in the physical world without human intervention. These robots are capable of performing tasks such as cleaning, sorting, or delivering goods efficiently. By using sensors, cameras, and actuators, they can navigate their environment and make decisions based on real-time data. Examples include Roomba vacuum cleaner, which autonomously cleans floors, and Amazon's delivery robot, which delivers packages to customers. These robots play a crucial role in automatic tasks and improving efficiency in homes and industries. Next, we'll see fraud detection agents. The fraud detection agents are specialized systems designed to identify and prevent fraudulent behavior in financial transactions mainly. These agents analyze patterns of behavior and detect anomalies that could indicate suspicious activity. By leveraging the machine learning and data analysis, they can flag potential fraud and alert the relevant authorities for further investigations. Fraud detection systems are commonly used by banks and credit card companies to ensure the security of financial operations and protect customers from unauthorized transactions. Next, we'll see traffic management agents. These are all the examples of agents. Traffic management agents are designed to manage a flow, that is a traffic flow of traffic in cities to reduce congestion and improve efficiency. These agents monitor traffic patterns in real time using sensors and cameras, allowing them to adjust traffic lights and reroute vehicles dynamically. By analyzing data, they can optimize traffic flow and minimize delays. Such systems are integral to smart cities around the world, where they help improve urban mobility, reduce pollution, and enhance the overall driving experience for commuters. Next, the main components of AI agents are architecture and agent program. What do you mean by architecture? Architecture of an AI agent, no, what it says, it outlines the structure that enable it to interact with the environments. It includes components like such as sensors, actuators, and agent program. The architecture defines how these components work together to process inputs and produce actions. Different architectures can be used based on the agent tasks, such as reactive, deliberative, or hybrid model. And what agent program says? The agent program is the decision making component that drives agents' behavior. It processes sensory inputs and determines the appropriate actions based on rules, algorithms, or learning models. The program ensures that the agent can achieve its goals by interpreting environmental data. It functions as the core logic of the agent, guiding its responses and adaptations. Next, simply what is architecture? The machinery or hardware that an agent runs on refers to the physical or computational platform that supports its operation. This includes the devices and systems that enable the agent to function and interact with its environment. Say, for example of hardware that that an AI agent might use include robotic cars, which allow for autonomous movement, cameras for visual perception, and personal computers for running software application and processing data. And what is the main role? The hardware provides the necessary sensors such as cameras or other detection devices to allow the agent to perceive its environment. It also supplies actuators like motors or display systems to enable the agent to take actions based on the sensory input it receives. Next, agent program. What it says. The agent program is the software that implements the agent function processing sensory input to determine appropriate actions. It runs on the hardware and to drive the agent behavior based on its perception. And what is the function of agent function? The agent function maps the sequence of all past perception to an action. That is the history of perception. It defines how the agent should respond based on its history of interactions with the environment. Next, we have the formula agents equal to a architecture plus agent program. So the agent is the combination of its architecture and the agent program. The architecture refers to the, what I've said, physical or hardware platform on which agent operates, such as robotic body, sensor, or computing devices. This hardware enables the agent to interact with its environment through perception and action. The agent program, on the other hand, is the software or logic that governs the agent's behavior. It processes sensory inputs, make decisions, and determine the appropriate actions the agent should take based on its goals and the environment. Together, the architecture and agent program enable the agent to function autonomously or in response to user inputs. So, coming into the summary, the AI agent or artificial intelligent agent operates through a combination of architecture and an agent program. The architecture consists of what I said, sensors, which allow the agent to perceive its environment, and actuators, which enable it to take actions. The agent program maps the percepts sensory input to appropriate actions based on predefined logic or learning models. Together, the architecture and the agent program enable the agent to interact with the environment and make intelligent decisions. This integration allows the agent to adopt, learn, and perform tasks autonomously. So that only we are calling it as intelligence, artificial intelligence. So thank you for your attention and interest in understanding AI agents and their components. We explored how architecture and agent programs work together to enable intelligent behavior. From sensors and actuators to the software that maps percepts to actions, each element plays a crucial role. Your engagement with this topic contributes to a deeper understanding of AI and its applications. Thank you again for your time, and I look forward to further discussions. Thank you once again.